Hello, Lacey. Look like only you. Oh, Sofa is here. Ah, Tiara is here. Okay. Yeah. Oh, today we have something very important to talk over about the chapter 12. Oh, there's more people here. Renita, Joseph, Jasmine. Hi, Renita. Oh, let's show my quiz.
Hi, Professor.
Hi. My webcam was twist.
Oh,
Look at the sheet in there. Okay, how are you, everyone? We're getting the end of the semester now. Chapter 12, right? Are you working on chapter 12? Yeah. Chapter 12, and next week chapter 13, the review for final exam. Then we're done for the final exam. Okay. So, and chapter 12, chapter 13, we should know how to use technology to do it. Okay. So that's why I want to focus on chapter 12, linear correlation and regression by using a TI 83 or 84. Both calculators can work. Okay. Let's see, anyone got a question here? Oh, and it's good. It's good. You go to the chat there to say hello to everyone, so we can keep your name, right? All right. So, someone sofa. Okay, sofa chair. Yeah, Jasmine. Oh. Because for those who did not come to the Zoom meeting, they had to post one homework questions from chapter 12, either question or solutions to show the participation, to earn the participation credit. So today, first, let me see, anyone got the questions? So we can use your questions first as an example to go over. Anyone? Joseph? Any questions?
Yeah, no, I don't have any questions this time. Thank you.
Okay.
I
Social.
posted on the week 11 discussions. I kept
Oh,
getting a question number 4 wrong on the homework.
oh,
And I posted it there and I posted like how I did it.
yeah.
Can you go over that?
Sure, we can go there. Let me go to find our discussions. So let's go to discussions. Oh, I need to open that one first. It's in the Math 160, right?
Yes, in week 11 discussions.
Week 11, okay. Let's go that one. What is this? Yeah, yeah. Discussion. Week 11. You said week 11 or week 13?
Week 11 is where I posted it.
Week 11. Okay. Week 11. Jasmine,
Yes.
question 4, right? Okay.
Yes.
Sure, we can go over this one. This is the chi-square test. Okay. And you can see the data is given as a matrix, right? We have row data and the column data. Row data is like you have to read the Peter, Ellen, Sue, 3 people. And the column data is before, after. Okay. We have both before and after a recent earthquake, that one. Okay. So we are going to find out has there been a change since the earthquake? Okay. So we are going to testing these two category, right? One category is by the name, and the other category by before, after. Okay. So we have all the data there. First, we need to input this data into our matrix. Okay. When you have column and row data like this, you always use a matrix. So I will go to PI 83 or 84, and you should go to input the data first. Okay. So we need to go to second. You have to paste the key, second x -1 for matrix. Second x -1 power. -1 power. That will bring the matrix. You will see your calculator, there's a matrix there. So when you place on second x -1, will pop out. Okay. We give you the matrix name, will give you the names. Okay. So you need to move on to the edit. Okay. So when you see your screen pop out the names, math, and edit, you will move to the right. Okay. Use the arrow key, move to the right, and select the edit. Okay. Then hit the enter. So you want the enter because that will give you by default the first matrix, number 1. Number 1 will show you matrix A inside the bracket like this. If you look at your calculator, okay, and it shows, my calculator shows a 2 by 2 because I did it before, okay, and our calculator always remain those prior knowledge memory. That's why you need to make an edit now. So you will go to the right hand side to go to the second x -1, go to edit and go to the matrix A. Just you will see the 1, you just hit the enter. Okay. So when you hit the enter on the matrix A, it will show matrix A. Okay. Your screen should pop out. Now matrix A and 2 by 2. So because I used 2 by 2 before, that's fine. But look at your data, question 4, we have 2 rows and 3 columns. So that's what we call, you always put the row number first. Row number, first number is for the row. So we have 2 rows. So 2 rows, 2 is good. Then by, I get like multiply by, we read it by 2 by 2, okay? So you have to change the second number. So just move to the right. Move to the right number here. Just use the arrow key, go to the second place. Change it 3 because we have 3 columns. Peter, Ellen, Sue, 3 columns there. So you have to change it 2 by 3, your matrix. First, you need to change that number. Okay. The dimension of the matrix. So after you done this, hit the enter. Okay. You hit the enter. Once you hit the enter, the matrix, we adjust the dimensions, we come out the bigger matrix. And there's 2 rows and 3 columns for you to enter the data. So you will go there. I type in on the chart for you to see what I'm doing, okay? So now I'm going to enter your data, 1780, right? I should share the screen of your data so everyone else knows what we talk about. Share screen, your work here. Okay. So now you should be able to see, everyone see your matrix and your question 4. And I will continue show you the work I'm doing on the chart. Okay. So I just enter the data one by one, follow the calculator position there. First number I will type in 1780 and move to the right side, enter, hit enter, always hit enter like a computer. Then move to the right is 1279 and hit enter again and move to the right. Under the SUI, SUI, we put the 1404, right? 1404, then hit enter. And then the calculator will go to the second row automatically. So on the right side of after, that the word after, you will put it in the data as 18 for the data data 1842. Okay, then enter, and the next data is 1339. Enter, and next one is 1438. So we need to enter all this data here, because this data is a survey of the voters of the 3 candidates. Okay, they plan on voting for the upcoming city council election, and this is the number before earthquake, after earthquake. Look like the number has changed, right? So we are going to see really the voter make a change because the earthquake before and after, okay, the election. So after you enter all the 1, 2, 3, 4, 5, 6 data into your calculator, then you just need the place. Okay, so you should have all these 3 numbers in, right? 1279, then 1404, then you will go to the next row, type in 1842, 1339, next number 1438, and under the second bracket supposed to be. Okay. So after you enter all this one, what you will do, just place of statistic, okay, stat, and move to test, to call the command. So we will go to the test and go downward, use down arrow key to find out the C. My calculator is TI-84. So I found out the C, option C is chi-square test. That's the test you need to use here, chi-square test. So after you find out that one, hit enter, you will see the screen shows observed matrix A. That means they already got the data that I just entered. And expected value, that's a formula from your book. They show the formula how to compute the expected value. Expected value just like the mean, okay? Like the mean of all the row number considered with the row number and column number in average, supposed to be not the matrix, what it should look like for each window here. So calculator already done for us. Okay, that's fine. The technology is so amazing, so quick. You don't need to follow that formula from the book there to do step by step. So matrix A, matrix B is all in. You just go downward to calculate. When you push downward to calculate, hit enter. I got my answer. The answer is chi-square square equal is 0.16361, but it's better put a 0 there, 0.1636. That's what I got. And you put the answer is 0.151. If you got it wrong, I think you can try again, get a similar question and try again. And I had to look at the problem again to see, do they require any decimals rounding off here or not? They only say use a level of the significance 0.05. Okay. And just ask you any change in distribution of the water preference since the earthquake. And report all the answer accurate to 3 decimal. Okay. So I should round up to 0.164. This should be the right answer, okay, for this data you have here. Can you change that your answer 0.151 now? So far? Can you change?
Yes, I'm sorry. I'm reopening it. So I'm changing it to
There's
1 point. Wait, what?
You come out the 0.151. But I came out the 0.164.
Yes.
I use matrix. You had to
And
use
that's correct. Yeah.
correct now?
Yes, that's
great.
correct.
Yeah.
Thank you.
You're welcome. Okay. Okay, so now, any other question you have? So if you're stuck on some problem, let me know, okay? This is the time we try to help you to get the solution for you if you're stuck on something. Okay? So try to use a matrix, okay? Because when you try to use a formula to calculate those expected value, very easy to make a mistake with a decimal point. And especially when you have to multiply, divide, it always will come on some decimal. And if you only use 2 decimals, sometimes not sufficient because, you know, the calculator can provide up to my calculator usually provide up to the 9 decimals there. So if you round all the 2 decimal at the end, though, you kind of miss it all the some numbers and never match the correct answer. So the best way, use your TI 8384 calculator, okay? And use a matrix when your data is given as a table like this. Just like the way I show you. I type in the chart there. That's the best way. And from here, also we give you the p-value. And this p-value is very difficult that you can read from the traditional table. From the calculator, they can give you instantly 0.92145. Okay. And if I round it to 4 decimal, usually is a 0.9215. And you can see this number is greater than the significance level 0.05, greater than alpha. If the problem asks you more, right? To ask you, is this how is this test statistic message given to us here, and ask you, is there any change after the earthquake? The water election make some significant change or not? Now you can say, no, there's no change. Okay, because look at the p-value so big, and the p-value is so large a number. Okay, greater than the alpha, we cannot reject the null hypothesis. And the null hypothesis for this type of equation, we're supposed to say the candidate and the earthquake before after, they are independent. There's no relationship, independent. Okay, and alternative HA should say they are dependent. They will affect each other. Okay, and based on our test statistic, the test statistic chi-square value is very small. It's 0.164 only. Okay? And the p-value is so big. When the p-value is so big, that means that our evidence is so close to the null hypothesis. When close to the null hypothesis, we cannot reject it. Okay. And we also need to understand for chi-square test, our null hypothesis is what? It's I think you should know about this one too. The candidates and earthquake, the two category, okay? Candidate and earthquake are independent. And alternative, HA, we will say, yeah, candidate, the vote to the candidate here, candidates and earthquake are dependent. For this type of problem, you need to write this. Okay? No hypothesis always assume no relation. They are independent. But that's why we can answer the question. Has been any change here? Then we have to say no change because we cannot reject that no hypothesis. And no hypothesis assume doesn't matter earthquake before after the voter can voting to the three different candidates about the same. Not much change. It's not significantly change here. So that's we needed to know about this type of equation. The null hypothesis always independent. Okay, and alternative is dependent when make some change. Okay, so this is from the chapter 11. And I hope you will move on to the chapter 12 this week. Okay. In chapter 12, we really have to use technology. Okay. Don't try to use the formula for chapter 12. Chapter 12 formula is very complicated. Our textbook didn't emphasize that one at all. They just show the formula and did not show you the work, how to apply the formula. No. They just, the author expect that we can use some TI-84 calculator to do it. There's an instruction on the TI-84 there. So I would like to go over that one, okay? Because chapter 12, you really need to use a calculator, okay? TI-84 or use some computer software. Some computer software like GeoGebra, that's a free product. If you are interested in learning that one, I can also show you. Okay? But our class is require everybody to have a TI-83 or 84. Because we are the online class and everyone from the different time, different work, different location. So I think a TI-83, 84 calculator is handier for everyone to use it. Okay, so I'm going to copy and paste some problem from, and same thing you can do, okay? When you're working on the homework as exercise, if you find some problem, you try this 2 or 3 times, like so far, and like adjustment, and never get the right answer, you can copy and paste that one into our discussions with your solution. That's good, because then we will know which is wrong, which is right. Okay. So I will go to assignments. Okay. When I come to the assignment, chapter 12, linear regression and correlation. This one is a useful tool when we have to compare 2 sets of the data values. Okay. To see 2 sets of data value, they are correlated with some kind of relationship will form a straight line or not. That's what we call linear correlation. Okay? And we use the point we collected from the data value, the pair data, kind of like a pair data, right? X, some value will give you some Y, X1, X2, X3, matrix Y3, and we put all the point, we plug them, we give you some scatter plot. Okay. So let me show you my screen. Can you see my screen now? My screen of the question 3. Did you see that?
Yes.
Okay. So that's the example of the scatter plot. Okay. That's for each data, and we have information from the horizontal. We used to call X coordinate, right? And for this application of the social problem is % female householder, no husband present, is put on the horizontal line, and vertical line is a % in poverty. Okay. So this is among United States study, the 51 states in the US, okay, including the DC. And each point is presenting one state information. If I pick up some point, for example, let me pick up a point here. You pick up the 12, okay. 12% female household here. That means some state they have 12% female household, no husband present, single mother, okay. And go to the left-hand side, you can see almost a match with 8% of the in poverty here. So that means if 12% of female household no husband, kind of corresponding to almost 8% of the poverty in that state. Okay, let's try to show us like this information, all the data, different location. So scatter plot, that's how we call. Okay, so chapter 12, you're going to deal with this real data, and we try to analyze. Are all this data here providing some straight line trend or relationship here or not? And when you look at this set of the data, you can see, look like the left-hand side, the data is more down to the lower part. And the right side on your right-hand side, the data kind of going up. So look like we have some linear correlation going up. The trend of the data is moved upward. This is what we analyze here. And we have some algebra formula to help us to determine how strong this correlation here. The female householder, % of the female householder with the poverty at home, what are the correlation here? Are they related or they are no relation at all? Okay, so that's what the study is doing here. So usually we can apply to this kind of social study, and we will find out what's the equation. This is the equation of the trend of this point here. That's what we call regression line. Okay, and like a female household, % of the female household is kind of like a variable X, and poverty like a variable Y, like an algebra class. We have some number, like a slope, and like some y-intercept, and minus some slope, and time % of the female household will equal how many % of the poverty. That's the equation trying to tell us here. Okay. So for this example, okay, this question 3, usually some student always will ask me about this problem because couldn't understand what's mean this one here. Okay, because the problem provided allowed the average poverty rate into the question here, and that kind of confusing the people. You don't need to worry about that. Okay, and those percentages for you to get the knowledge about some social study about the income. So how we decide, how can we, which of the below is the correct linear model for predicting the poverty rate from the percentage of the household with a female head. Okay. So what do we do? Since the equation is given to us here, you just need to analyze. Okay. I think I need to write something here to give you some idea first. Because in chapter 12, we must use the concept from algebra. And remember, in algebra class, we have y equal mx plus b. Remember this one? I need to stop sharing and show you my whiteboard. I just typed something in the whiteboard. Here, share. Remember, in algebra class, we have y equal mx plus b. Remember that? M is the slope, b is the y-intercept. Okay. In algebra, we like to present the slope first, then y-intercept. B is the y-intercept. But now, in statistics, we tend like to show this way. We use a y-hat. We prefer to put a hat on the top because our y is not like algebra. When you input some x, will give you exactly the value of the y there. Our y is kind of predicted value. Okay? We are going to analyze this point and try to form some line there, go among all the points with the shortest distance to all the points as possible, and determine one estimated line. That's what we call y-hat. Okay? Then we would like to show A first, the y-intercept, where we cut the y-axis first, then plus B presenting the slope times the x. In statistics, we prefer to use y-hat equal A plus bx. But you just compare with algebra for you to understand. Now the B actually is the same as the M slope. Okay. And algebra formula, the B is a y-intercept. Okay. But we better stick with our algebra format. A is presenting y-intercept. And then B is presenting slope of the line. We are going to use a straight line to estimate the straight line will go among all these points here to give us some idea, the trend of the point moving on here, their relationship. That's what we are doing in chapter 12. So in chapter 12, it's very important. You must be able to find, plot the point, right? Plot the scatter plot. You must be able to plot this kind of point. And those kind of points, just x equal what, y equal what, you just put that point like algebra class. Okay. Scatter, we call scatter plot, the graph. Be able to analyze what's been that graph. Then you are needed to find linear correlation, coefficient. That we call R, small r, equal what? Because this one will show the strength of the line. Okay. Strength of the linear correlation. How strong they correlated here? If we increase the x, increase the y, or increase the x, decrease the y. That's what we try to find out. Okay, this one. Then one more thing we need to know. So I'm going to put the important point. Number one, you must be able to plot the scatter plot. Okay, and number two, find the linear correlation coefficient R. Okay, and number three is determine the equation, regression equation, the regression equation. equation. The regression is the one we call the line go among all the points with the shortest distance close to all the points as possible. That's what we call regression. Okay, so you need to be able to determine this equation. What is this equation? It is, and usually we use y hat equal a. You need to find out what's the a and what's the b and time the x together. Okay, and I know sometimes you will see the exercise they did not present that way. They may present the y hat first. Okay, they will say y hat equal a times the x a plus b. That's okay too. You just need to understand the number attached with the x is the slope. Okay, and numerical number itself alone, that is the y-intercept. And some author, they put the algebra format, the second one, AS plus B, okay? But actually in statistics, the correct way, we should present the y-intercept first, then slope times the x, okay? So for the chapter 12, you need to do this. And one more thing, you need to know how to find out the R square, okay? Somewhere they shows the R square R go the square power like this equal what? Or somewhere they like use the capital R go the square power equal what? Okay. This means coefficient of determination. This will determine percentage of the variation, percent of variation covered, not all, you should say explained by linear regression. Linear regression. That because our straight line is an estimated line, and we want to see this line, how good it is, how many percent covered. Okay, so that R square will tell us that. Okay, so I think you need to know 1, 2, 3, 4. And one more thing you need to know is number 5. You need to compare R with the critical value of R. So we have a table I sent it to you already. Is under the statistical table, I think called table 6. That one will show you the critical value. We need to be able to compare. The rule is this: if absolute value to R greater than critical value, then the linear correlation is significant. So we can use it to find the predicted value. Okay, just like meteorologists, right? How do they know that Saturday we are going to have rain or Saturday we are going to have wind? Because they use similar to this linear regression we are studying in chapter 12 here. They will put the morning one factor, morning one x, right? So far we only working with one variable x, but for the weather report, there's a pressure, there's a humidity, there's some other wind, the direction, some other things. They put it together to give the prediction for us. So we can use the regression line to do the prediction. Only the linear correlation R is significant. Okay, remember this rule because one of the questions on the exam may ask you that. And let me see what else. Okay, so if absolute value of the R is less than critical value, then we use Y bar for the best prediction. What do you mean that? Because if the absolute value of the linear correlation smaller than the critical value, that means the R is not significant. Okay, so we cannot use a linear regression tool for prediction. So we need to use a Y bar. Okay, this is very important concept here. You need to use the average of all the Y, and usually the problem will give to you. If problem did not provide the Y bar information, we need to add up all the Y value, find out the average. Just add up, divide, right? If they give 7 data, just add up 7 data, divide by 7. That's the mean Y bar. Okay. So this is very important for your chapter 12. Okay, what I wrote here for you. I bet you better take the note of this. Okay. Then I will use some example to show you how you apply, how you use it. Okay. And you can see the homework exercise here. Some problem will give you the scatter plot. They ask you to find out one equation when matrix that one. And I can tell you for the question 3, you can see the group of the point, the low side on the left and the upper side on the right. So we should have something going up here. But if you put some straight line go among all the points, okay, now I'm going to look at that graph again. So I'm going to share the question here. So you know what I talk about here. Or maybe I should have copied that one. No. So now you can see my screen, right? There's a scatter plot there. And the correct answer, you should look for the y-intercept should be below the 6. Because y-intercept, right, cut on the vertical line here. You can see percent in poverty, the lowest number is 6. So must be some number lower than the 6 if you draw a line passing through, okay? Probably I should have copied. I'm going to see, can I copy this one? Put it in the whiteboard. Control C. And bring to here. Let's see. Yeah, I got it. Okay. So I stop share that one. Then I share again with you using the whiteboard. Because whiteboard I can write better. And the whiteboard. Shoot. Okay. So now you should be able to see that the question 3. And I was talking about that we are finding a regression line to go among these. So I'm going to draw that line. Okay. So let me get the pen. Get the pen, red color. The line is supposed to go like this. Okay, let me see, can I draw here? It's not a straight, it's supposed to be straight. Okay, let's do again. Because I'm using the mouse as my pencil, so it's very difficult to draw. I'm using this mouse, my mouse. So let me do again. So the regression line is look like this way, okay? I don't know, should go more to the left side. Should go more to that side. Okay, The regression line is supposed to go among all the points and closest to all the points as possible. Okay. So it should have this concept here. Then our y-intercept is supposed to be some number below the 6, right? So you look at the choice, multiple choice here. The first one is 3.7, seems okay. Second one is 6.7, is about 6, doesn't look right. And the third one is 19.49, is even worse. So 19 is on the top here, we go down, okay. And the last one is 3.2, okay. So look like 3.2 or 3.7, this choice 1, choice 4, they are possible to be the solution. Now, just one more thing, look at the slope. Look at the line I draw here. Is the line going up? It's supposed to be a straight line going up, and it's going down like this, okay? So you see, the slope is supposed to be positive or negative? How do you think? The line is going up. Our slope should be
Positive.
very good. So now you have an answer for your question. The answer is this one. 3.2 plus 0.7 multiply female household like variable x, because the slope 0.7 carry the positive sign here. And look at this positive sign. Just because we look at the line go among the point, it's going up positive. That's how you decide. The right choice is this one here, according this data I have. Okay. So this one is kind of give you the concept about the application from the straight line, slope, y-intercept. This point should be below the 6 here, right? And slope should be positive. So even we don't know original data they have, we can look at the multiple choice to find out the right one. Just apply the concept. Okay, so this is the one of the good example to show you, because every semester always someone asks me about this question, this one. Let me go to look at another one. Another one is using your technology to find out the linear correlation when you are given a data, right? Original data. For example, question 4. Okay. Look at the question 4. And I need your help to do together because we have a lot of data here, right? And we need to input this data into your calculator, TI-83 or 84. Okay. So I'm going to solve this one. Okay. And I think I'm going to copy this data into there. Let me see which data is shorter. Maybe question 6. Question 6 we have about the same, right?
Professor, excuse me, would you be able to go over number 12? I had a
Number,
tough time with that one.
oh, okay. We can go your question first. Yeah. Question 12. This one, X and Y.
I'm sorry. Yes, question number 12.
Yeah,
I struggle with that one.
run a regression analysis, right?
Pardon me?
We can share with your data. How about that?
I didn't hear you. I'm sorry. Can you repeat that?
Yeah. Can you share screen, share your data?
Oh, okay.
Yeah,
Let
just
me
click
give that
on,
a
yeah, you open up and click on share, then we can see it. Okay.
oh, okay. Well, let me give it a shot. I'm looking from my phone, so just give me a moment. Okay.
Okay, sure.
All
No.
right. Thank you.
Mm-hmm.
Professor, I'm not logged in. Is it possible for you to just go to number 12 on the assignment?
It's
It's in with,
okay. Just use
pardon me.
mine. Just use my data.
Okay, I'm sorry.
Okay.
Yeah.
That's okay. Because our question is very similar. Just
Yeah, because
data change only. Okay.
I know we're at like the end of the class and I don't want to hold everyone up.
That's okay. We still have 8 minutes. Okay. Okay. I'm going to do quickly. Okay. So Control C. I'm going to bring this one to the whiteboard. Where's my whiteboard? Oh. New. Okay. And let me bring to the whiteboard. Okay. So I think I got it. We just have, for this problem, you have to be careful. Yeah, this problem, they say, they give you the response variable first, okay? When the problem give you a response variable, that means give you the y first. And if they give the y first, you need to plug in y and to solve for x, okay? So let me redo this again. Control C. So can you see my screen now? The whiteboard?
No, we can't see it.
You cannot see it? Let me see. Where's mine? Okay. Let me share the screen again here. Share. Okay, can you see it?
Yes.
Okay. Now you can see it, right? All right. Okay. So this problem here, one thing we have to be careful is when you read the statement here, it says verify the correlation is significant at alpha equal 0.05. If the correlation is indeed significant, predict that value, okay, for the explanatory variable. That means we have to find the x, not to find the y. Usually our problem is looking for y. Y hat predicted the value, response variable we call. But this problem is different. Ask you to find the x. So they said, we give you the y as 23.8. Okay. So what is the x? So we need to find out this one first from x and y. Okay. This one take time to input your data into your calculator. If you can do quickly, we can do that. Okay. Maybe
Okay.
go to your calculator, press on second step. You will see edit, right? Step, edit. Hit the enter, and you will see L1, L2. We are going to use L1, L2. So you need to clean out L1, L2.
Okay.
Okay. So go up and hit the clear and go down. And go to another column. Go up and clear and go down. Okay. So let's input
Yes.
all the data. Okay. 43.3. And it's good. More than one person do it because we couldn't make a mistake as well. 54.3. Then 53. Then 10. Then 17.5. and 63.9 and 54.2, 42.7, 71.8 and 43.9, 48.1. Okay, I finished the first column. And the second column is Y. We have data 64.4, 84.5, 108. And we have -9. Be careful. When you see the -9 there, you have to type in the minus sign inside the parentheses. Okay, minus sign inside the parentheses at the bottom there. Don't use the subtraction symbol. And
Okay.
18.8, enter. Then 77.3, then 76.2, enter. 39.2, enter. 118.3, enter. 67.8, enter. 12.1, enter. Okay, I finish all. After you finish data entry on your L1, L2, okay, then click on Stat and go to Test. No, you don't. Yeah, you can go to Test there. You're not going to give you more information. Okay, just go downward. You will find out the last one there, F, linear regression t-test. Click on that, enter. Okay.
Okay.
Then your calculator will pop out the X1, X list, the L1 there, right? And the Y list, the L2, frequency 1, you don't touch anything, just go downward. Then you will see beta and rho, not equal 0, less than 0, greater than 0. Enter with a highlight on the not equal 0, okay?
Mm-hmm.
Then go downward to calculate, hit enter, down. Okay.
Yes.
Then you will find out your regression equation. So you need to write down your regression equation now. So regression equation is regression equation, what you have to write in the format of y hat equal a plus bs. Okay. And
Right.
so you need to replace a by negative 23.9429. Okay. Keep a more decimal is better. 94299, I will keep a 5. Then plus b replaced by 1.85393. Okay. And put the x behind. So after you done this, you are going to have this is the linear regression equation. Okay. So after the calculator will give you, okay, the TI-8384 will give you the equation y hat equal negative 23.94299 plus 1.85393 x. Okay. So this should be coming from your TI-8384. Then the problem said we have given you a value of the 23.8. So you need to replace that the y hat by 23.8 equal, okay? And copy that whole equation here.
Mm-hmm.
Copy the whole thing. Control C and copy over here. Okay, and solve for x. So it's just like an algebra question, try to find out what's the x. Okay, so x will be 23.8. In that this number here is negative 23. So you move to the left hand side will be plus, right? Plus
Right.
23.94299. And you need to add on these two numbers. Okay. After you add on these two numbers, you are going to divide by this coefficient next to the x here. Divide by 1.85393. Okay. And we give the x. Okay. So let me finish this one to see what's the answer. 23.8 plus 23.94299. Then we divided it by 1.85393. Okay. Then hit enter. I got the answer 25.75. And let's see how many decimal they want. And they say accurate to 1 decimal. So to 1 decimal, I will round it to 25.8. Right.
Mm-hmm.
It will be around that number. If we input the data correctly, didn't make a mistake, this
Yes.
is supposed to be the correct answer.
Okay.
So the key is this problem give you the y first, okay? So you need after you find a linear regression, y equal a plus bs, replace a, replace b, you have to replace y by that number they give to us, 23.8, and solve for x.
Mhm.
Okay? Solve for x, you have to remember, this problem is ask you to solve for x, okay? It's ask you to solve for x. So it's very different from other problem there. Other
Right.
problem there is always you have x and find out what's the y, right? But this problem is ask you to solve for x, okay? So you need to find out x equals something. All right.
Okay. Mm-hmm.
So if you
Okay.
follow this way to do your data, you should get it. Okay.
Thank you.
You're welcome. Okay, and this is a challenging one, yeah. This one also, a lot of people ask me, why I couldn't get the correct answer. Because a lot of people plug in the 23.8 into the X. And that's why never match the correct answer. Okay.
Right. Right.
So
Okay. Thank you very much.
you are very welcome. Okay. You have more questions, you can just post a copy and paste and put on the discussion. Okay. Like it just been did that way. So we go there to take care. Okay. All right.
Right.
Any more questions?
I'll just put it in the on the discussion.
Yes, put it on the discussion. So that way, because discussion board is easier for me to write out because there's a mathematical symbol to use. Here, no. You have to be creative to think how can I present it.
Sure, no problem. Thank you.
You're welcome. At least this will get you start working on something, right? Okay, so I hope everybody try to practice with your TI-8384, okay? And enter the data. If they give the raw data, you have to input the data. State, edit, L1, L2. Clean out the L1, L2 first. Clear. Then input the data carefully. And find the equation, find the linear correlation. For this problem, I think we have also linear correlation here. Let me see. Because that's also another question. Always will ask you find out linear correlation. Yeah. After you done the test, you can see it. You can see go through, calculate. Yeah. Yeah, you go downward. A lot of information behind. Not only that the equation of the regression line, the calculator also will give you R squared equal 0.664. Usually pick up the 3 decimal. Then the R round to 3 decimal, then R equal 0.815. So this is usually question when I ask you, what's the linear correlation? The strength of this straight line is that number between the two variables. Okay, between x and y is 0.815. And you know the number close to the positive one or close to the negative one, we consider strong correlation, 100%, right? So
Mhm.
0.8 is close to the 1. So it's relatively considered strong one. Okay. And R square is trying to show how many percent, okay, our regression line, how good it is. So this is about 66.4. We change the percent. Usually we like to change it to percent. Multiply percent will give you 66.4% of the explanation being covered, being explained by our linear regression. Not
Mhm.
the red line, okay, covered 66.4%. So not too bad, more than 50%.
Mhm.
Yeah.
Okay, well,
Okay.
thank you so much. I'm definitely going to have to practice that one. I had got
Sure.
stuck on 2, but the other one I'm going to put in the
Yeah.
discussion.
Yeah, you just copy and paste, put on the discussions.
I
Okay.
sure will.
Yeah. All right.
Okay, well, thank you so much. Okay, you
You're
have a
very
nice evening.
welcome. Yeah. Thank you.
Thank you. Okay, bye-bye.
Okay, bye-bye. See you everybody this week.
It's just us.
Oh,
It's just us.
everybody's running away already. That's okay. Some people they have got to go.
Right, right,
Or they are going to the dinner, right?
right. Okay,
Okay.
well,
So
thank you so much. I'll actually review the recording
yeah.
and practice, okay?
That's right. You can also review the recording. Yeah.
Yes. Thank
Good.
you so much, Professor.
You are very welcome.
You have a nice evening, okay?
Yeah. Thank
All
you.
right.
You
Thank you.
too.
Okay,
Bye-bye.
bye-bye.